Problems from 6-1. First one says find the area enclosed by these three graphs. So I'm going to make a graph of this. And so x plus y equals 4 would go through 0, 4, and 4, 0, and 0, 4. X minus y would be add y to both sides and get y equals x, which is this line. This one, if I solve for the first one, if I solve for y, I get 4 minus x. And the last one, if I solve for y, it's going to be y equals a plus 4y intercept with a negative 3 slope. So it'll go down 3 and over 1. So this intersects at 1 and 1, because that's both on this line and this line. And so the area that's enclosed is there. And so I'm going to split this into two pieces, this triangle and then this triangle. So I'm going to have the integral from 0 to 1 of the top curve would be 4 minus x minus the bottom curve, which would be 4 minus 3x. Plus, then the area in here, the top curve would be 4 minus x minus the bottom curve would be x. And that would be from 1 to, those intersect at 2. And you can check that out. We could put 2 into here and we get 2, 2. And I believe if we put 2 in here and 2 in here, we get 4. So this becomes the integral from 0 to 1 of 4 minus 4 is 0 minus x plus 3x is 2x. From the integral from 1 to 2, 4 minus x is 4 minus 2x. And so if I integrate these, this becomes x squared evaluated from 0 to 1 plus 4x minus x squared evaluated from 1 to 2. So that's 1 minus 0 from the first one plus 8 minus 4 minus 4 minus 1. 8 minus 4 is 4, minus 3 is 1, 1, 2 is the answer. This one. So let's get a good picture of the graph. At least I'll try. So this is y equals 1/5 x. So that's a real low slope. It goes from, has to go over 5 to get up 1. So something like that. And this one, well, if I put in 0, I get 0 over 1, which is 0. If I put in 1, I get 1 over 2, which is a half. And if I put in 2, I get 2 over 5, which is 2/5. So this goes something like this, and then it's going to come down and get closer and closer to 0. And then when I put negatives in, it's going to be the denominator is going to do the same kind of thing. The numerator is just going to be the negative of it. So it's just going to do something like this. So the area between is going to be that and that. And so they intersect at 0, and they also intersect out there and there. So I need to find where these are equal. So x over x squared plus 1 equaling x over 5. What I could do is multiply both sides by 5. And that would get rid of the 5 here, and multiply both sides by x squared plus 1. And I can do that and not lose any solutions because x squared plus 1 is never 0. And x squared plus 1. So those would cancel, and I don't lose any answers, so I get 5x equals x times x squared plus 1, and I could multiply that in there, but I don't want to. Now, if I tried to divide by x, x could be 0, and so I could lose a solution of 0, which I know is one of them. What I should do is maybe take the 5x over and have 0 equals, subtract 5x from both sides, x times x squared plus 1 minus 5x. Factor out the x, and I would get x times x squared plus 1 minus 5. And this says x can be 0, because I can set this equal to 0 and this equal to 0. That's x squared minus 4. So if I said x squared minus 4 equal to 0, add 4, I get x squared equals 2, and x equals plus or minus the square root of x, add 4 is 4, square root of 4, which is plus or minus 2. These graphs are both intersect at plus 2 and minus 2. Now, because of the symmetry, I'll just find the area of this side and multiply by 2. So I'm going to take 2 times the integral from 0 to 2 of this curve, x over x squared plus 1 minus 1/5 x. And this is pretty easy to integrate, and since these are subtracted, I can do, and there's no square, I can separate this. So I'm going to make it the 2 times the integral from 0 to 2 of x over x squared plus 1 dx minus 2 times the integral from 0 to 2 of 1/5 x dx. And if I let u be x squared plus 1, du would equal 2x dx, and dx would be du over 2x. So I would have, for this first one, 2 integral, I'm changing to u, so 0 squared plus 1 is 1. 2 squared is 4 plus 1 is 5 of x over u. Dx is du over 2x. X is canceled, and I can integrate that pretty easily. The 2 can come out. Minus 2 integral from 0 to, actually I can just integrate this. Well, I'll leave it here. 0 to 2 of 1/5. I can take the 5th out. 1 x dx, which is going to be 2 over 2 is 1, and 1 over u integrated is ln of u, and that would have the new limits of 1 and 5 minus 2 over 5. Integral of x is 1/2 x squared, evaluated from 0 to 2, still the old units, 0 to 2. And so I get ln 5, absolute value of 5 is 5, minus ln 1, which is 0, minus, the 2's cancel, so I get 1/5 of, put 2 in there and I get 4 minus 0, so it's ln 5 minus 4/5. Okay. 42 says find the area bounded by these two. X plus y equals 1 would go through 1 and 1. Be a line. If I solve for y, it would be y equals 1 minus x. And this one, neither x nor y can be negative because it says square roots of them. And if I put something in here for x that would be easy, it might be like 1/4. Or let's do some more here. If I put in 0 for the x, I would square both sides and y would be 1. 0 for the x, y is 1, so it goes through that point. And same, it would go through 1, 0. So now I'll put in 1/4 because that's easy to take square root of. Square root of 1/4 is 1/2. If I put 1/4 in here, I get 1/2. And that would equal 1, so it goes through the point 1/4, 1/4. So this must go something like that. So the area enclosed would be between them, and it would be the integral from 0 to 1, 0 to 1, of the line, which is 1 minus x, minus this one. Now this one would be, if I tried to clean this up, I'd subtract the square root of x and then square both sides. So I'd have 1 minus the square root of x and then squared. That's what y would be. Okay? Well, we can do a little simplifying here. So that'd be the integral from 0 to 1 of 1 minus 1 is 0. So that's gone. We'd have minus x, and then we'd have minus a minus, which would be plus this. We have the quantity squared. Excuse me. Let's square this quantity. So 1 minus the square root of x times 1 minus the square root of x. I can't combine that ones right off here, but I will be able to do something with that. So I'm going to get 1 times 1 is 1, minus the square root of x, minus the square root of x, minus 2 square roots x, and then minus square root of x times minus square root of x is plus x. So this is that. So I've got 1 minus 1, which is gone. I got minus x, minus x, which is minus 2x. And then I've got minus a minus 2 square root of x, which is plus 2 square root of x dx. I'll write it down here so you can see it. So I have 1 minus x minus this, which would be minus plus minus. So I got a minus x and minus 2x. The 1's cancel, and I got a plus 2 square root of x. So this becomes the integral from, well, I'm going to integrate now. So the integral of that is minus x squared. And this is 2x to the 1/2 So I'd have to raise it to 3/2 and multiply by 2/3. So it's going to be plus 4/3 x to the 2/3. 1/2 goes to 3/2. 2/3 out here. 3/2 evaluated from 0 to 1. So if I put in 1, I get minus 1. The square root of 1 is 1 times 3. A cubed is 1 times this is plus 4/3. Minus, if I put zeros in here, I get 0. So I get minus 1 plus 4/3, which is 1/3. $48. So what do these look like? Well, if I put in, I can't do 0. ln x comes up like this, and if I divide it by x, which is getting bigger and bigger, that's going to lower this side. And when x is small, it's going to make it bigger. So ln crosses at 1, 0. And it's just going to raise this up a little bit and bend this down a little bit. So it's still going to look like an ln curve. And let me just verify that with you as soon as I can figure out where I put my calculator. Show you what I mean. So if I go up here and turn that one off, come down here and type in ln x, ln x, close parenthesis, and go zoom 6. Actually, stop that. Let's go zoom 4, see a little closer. That's what ln x looks like. Now let's divide it by x. ln x divided by x. Okay, so it lowered the part in here and raised that up here, but it's basically goes through there. And this part goes up and then it starts coming down. Okay, so it actually comes down out here. Okay, now what's the other one do with the ln squared? So let's see what ln x squared looks like. So I'm going to put insert a parenthesis there and put 1 at the end just to make sure I get the whole thing squared. And clear that one and graph that. So there's ln x squared. Now let's divide that by x. Divided by x, and so it makes it come down and then jump up like this and go like this. So they kind of cross there at 1, 0, and they also cross someplace out there. So I'm going to set them equal and see if I can find that. So I have ln x over x equals ln x quantity squared over x. And if I multiply by x, I'll lose the solution, potentially x being 0. So, but I will do that anyway, and know that I might lose the solution at x equals 0, but the x can't be 0 because ln doesn't exist. So I'm not going to lose the solution, and those are gone, and so I've got to find out when ln x equals ln x times ln x. So if I divide by ln x could be 0 at 1, so I might lose the solution. So I'm going to bring 1 over. So I'm going to have, I'll subtract ln x from both sides. So I'll have 0 equals ln of x quantity squared minus ln of x. Factor out an ln x. So I want to know when ln x is 0, and that's at 1, and when ln x equals 1. ln x equals 1 when we put in e. So this is e. So in this problem, we should be integrating, oops, I got that off the screen. I should be integrating, the top one would be the first one, ln x over x, minus the bottom one, ln x quantity squared over x, dx from 1 to e. Now, these both will work pretty nicely if I let u be ln x, because then du would be, I can multiply by x. So this x, when I put d in here, will cancel both of those, and I'll have the integral. Now, if I put 1 in here, ln of 1 is 0, and ln of e is 1. And this would be u, and the x's cancel, minus u squared, and the x's cancel, du. This x cancels both of those x's out, which is 1/2 u squared minus 1/3 u to the third, evaluated from 0 to 1, which would be 1/2 times 1 minus 1/3 times 1, which is 1/2 minus 1/3. Minus, put 0 in, I get 0. 1/2 minus 1/3 is 1/6. Okay.